In this video, I'm going to explain, I will be covering these three things. First of all, I will be talking about the three-way handshake, the SYN packet, sync, acknowledge, and why these are so important when we are doing the Nmap scanning. Okay. Second of all, we will talk about how Nmap uses these three-way handshake to figure out whether the port is happening or not, and what's happening on the other end of the target. And the last thing I will be covering about the different types of the state of the port, whether the port is open, whether it's closed, whether it's filtered, or open slash filter, closed slash filter. So I will be explaining all of these, like what does it mean, what are these states of ports, and how does Nmap decide these things. So without any further delay, let's get started. Okay, so let's talk about the three-way handshake. It is very important to understand when we are doing the port scanning. Okay, so there are different states of the port, like you will see sometime the port is open, or the port is closed, or the port is filter slash open. So we will understand what these mean, but before that we need to understand the three-way handshake. So let's understand this first, and then we'll move into that. And to understand this three-way handshake, I'm gonna explain it with the analogy. It is a simple analogy. Once we understand that, we will then move into a technical explanation. So for example, this is the analogy over here, and let's say you are in a crowded room and you want to talk to a specific person. You will be like, hey, can you hear me? And wave at them, and they will, if they can hear you, they will be like, yeah, I can hear you. They will wave back at you, and then at the end you will be like, okay, great, I can hear you, you can hear me. You will wave at them, and and boom, both of you are ready to communicate, both of you are ready to share the information and communicate, right? So similarly, very similarly, the three-way handshake does the same thing. Now, let's say you want to connect to a target machine. What you will do is you will send a packet, SYN packet. Okay, this is specifically, this is very important to understand. You will send the SYN packet to the machine, to the target machine, and be like, hey, I want to connect. And inside that packet, what will be, inside that packet will be your machine IP, like from where it came, the packet came, and to the target IP will also be there, like to which you wanna get connected, and on what specific port. The port number will also be there, and in the flag section, the flag type will also be there. It is sync, to synchronize with the target machine. Okay, so that is why it is sync, and these are just some sequence number. It's not important. It is important, but let's move on from this. The target machine received the SYN packet. Now what happened next? Let's understand this in this step 2. So now the target receive our SYN packet. The target decide, do I have something listening on this specific port that is specified in the SYN packet? Okay, so over here we have, it will check, the target machine will check. If yes, means the port is open, the target will send back, I got your message on this specific port, and here is my this number, and I acknowledge that, yeah, I got your packet. So it will now send the target machine that we were trying to connect will send the sync hyphen ACK mean acknowledge packet back to our machine. So now, it in that it will be the target IP machine in that packet, and then 2 will be our machine IP, and the port will be same that we were at first trying to connect. And now in the flag section, we have the sync which was sent by this and acknowledges is from this. So this will go back to the our machine, and this is the case only if the port is open. Now if the port is closed, we won't get anything. We will not receive the our machine will not receive the acknowledge packet, because nothing is listening on that port. So it will just send the flag. What this means, it's reject or kind of reset, and that is used for to in a way tell you that, yeah, the port is closed. Okay, now in this step, that the port in this scenario, when the port is open, I told you over here that when we get receive the sync acknowledge packet, we will be like, our machine will then send another packet, in which there will be your machine IP target, and the flag will be acknowledged. Now not sync, not SYN-ACK, just ACK flag to the target machine, and in a way telling that yeah, I confirm that you can hear me, I can hear you, let's start communicate, let's establish the connection. This is how the information is being shared between devices. They first of all they do complete three-way handshake, and the three-way handshake only work for TCP ports, not the UDP. UDP does not care about the connection, whether you get the data or no. Okay, so I hope you get a little bit idea of how the three-way handshake works. And let's talk about why this is important. I told you that it is important to understand. Let's say you are doing Nmap scanning on a specific target, and it says, let's say you do the scanning, and in result you get that this specific port, let's say 443 TCP port is open. How does that happen? Remember the acknowledge, sync, acknowledge, acknowledge. This is how the Nmap send a sync packet to port this, right? And then the or any port that you specified, or the top top ports, or the top 1,000 ports, or all of the ports, send the same packet to those ports. The target, if the port is open, this target will send back the packet, meaning that the port is open, and Nmap will then say yeah, it will tell us yeah, the port is open. If we get the RST packet, the Nmap will result it out like report it out that the port is closed. And this is exactly what port scanning is. Hope you understand now. Now let's talk about the different state of the ports. Let's say you are doing the Nmap scanning and you get some result, and in that result you see some ports are open, some ports are closed, and some ports are open slash filtered. So let's understand the reason behind that. Okay, so for example, let's say a service is listening on this port, right, and is ready to accept connection. Meaning, let's say you send a packet, send packet to 443 port on the target machine, and it gives you back the acknowledged packet, meaning the port is open. So it means the port is ready to accept connection. And what actually happened behind the scene is Nmap sensing packet, target respond this, and map report it as open. So that's how it figures out that the port is open. Okay, and another most important thing why we care about the open ports is that over here you can see open ports are our main target. They might have some vulnerability that we can exploit. And don't worry if this does not make sense to you. This is just practical knowledge, theoretical knowledge. I will be doing the practical as well throughout this series, so we will understand all of this very better. Now another state is closed state. You already understand that if we receive don't receive the ACK packet, we sync ACK packet, it means that the port might be closed, right? So this is it, and then it's basically kind of saying that I got your packet, but nothing is listening here, so go away, and it will just result it as the port is closed. And then we have the another state, which is filter state. What it means, a firewall or security is blocking your packets. You cannot tell if the port is open or closed because you are not getting a clear answer. Okay, so when you send a sync packet or to a filtered port, one of these two things can happen. For example, a firewall silently drops the packet sent from the nmap, like Nmap send the sync packet, firewall receive our sync packet. Firewall has the policy or the rule that says that drop the packet or block this packet. So it will do nothing. Firewall will take action, do nothing, and drop your packet. And while all this happening, Nmap will wait, and if nothing comes back, it will say that Nmap will report it out as filter because it never got any proper response. The another scenario could be like firewall explicitly reject our packet. For example, we send the sync packet, the firewall receive our sync packet, and it decide to block this, and firewall action will be like send ICMP packet to the machine that where the scanning is happening for, tell them that this destination is unreachable. and Nmap receive ICMP error, and this is how Nmap resulted out that the port is filtered. So either way, the firewall is not giving us a proper response from which we can understand the proper state of that specific port. And the fourth state over here we have is the open slash filtered. What it means is the port is probably open, but you are not 100% sure. The Nmap is not sure. This state most probably happened in the UDP port because it don't have any three-way handshake. It does not care whether it receive our data or it send us the data back properly or no. So most probably this happen in the UDP port. We'll talk about this later in another video. Okay, and this fifth state, the closed slash filtered, cannot distinguish between whether the port is closed or it is filtered, because in closed port the port explicitly reject your connection because it is not open, the port is not open. And same is the case with filtered. If there is a firewall, you send some packet, sync packet, the firewall will drop the packet, and either way you don't get proper answer that whether the port is closed or it is filtered. So this is that. And look at this, this is one of the practical scanning method we are actually coming across in different when we are doing different giving different exam. This is for OSCP, could happen in any exam. This is just the first of all what we will doing is we are doing the port scanning and figuring out what ports are open, what ports are closed. Don't worry if you don't know anything about Nmap or different types of the Nmap scan. I will be explaining everything in this series, so don't have to worry. So this is the Nmap tool, network mapping tool. This is mean just sync scan, like give us fast result. I'm gonna explain, don't worry later. And this means that -p mean specify the port, and this means all of the total number of port, and this is our target machine. It will do its scanning and check out the packets and three-way handshake stuff, and then based on that it will give us the result. The port 22 is open, port 80 is open, port 445 is open, and these are its services. So from that what we learn is these three ports are open out of the total ports. And then what we gonna be doing is we will find out the actual version if of the port, and to do that we will be using another flag of the Nmap, which is sv this find out the version of the ports. And this we are here specifying those specific ports that were just open. So it will do again scanning and report that yeah, these ports are open, these are its specific version, right? And from that version, from these version, we can look search on the internet if any vulnerability exists for these or not, that we can explore later, right? So I guess that's pretty much it for this video. In the next video I will explain what is Netcat and how we can use it to do port scanning. Okay, so see you soon in the next video.